Hi guys, today we've got 4 interesting factorization questions. The first one is x to the 9 plus 7x to the 6 y cubed plus 7x cubed y6 plus y to the 9. So our goal here is to factorize, right? Well, since everything's in terms of x, let's just evaluate our x terms. We've got x to the 9, x to the 6, x cubed, and then our y terms, y to the 9, y to the 6, y cubed. And you notice that these two terms, x and y, they're symmetric. And this whole expression looks quite familiar to an identity we know. We know that a plus b cubed equals a cubed plus 3a squared b plus 3ab squared plus b cubed. Now you might ask, why have we used cubed here and not powers 9, 6 and 3? Well, 3 there, but whatever. Well, if we let x equal a, so let x cubed equal a and y cubed equal b, our expression now reads the following. So we've got a cubed plus 7 x to the 6 becomes a squared b plus 7b squared a plus b cubed. Now notice how we're almost in the format a cubed plus 3a squared b plus 3ab squared plus b cubed. And the way we can bring this about is by separating these two terms here in the middle. So what we can do is we can say this equals a cubed plus 3a squared b plus 3ab squared plus b squared, and then plus 4a squared b plus 4ab squared. Now, as we know, this part here, our first bracket, simply becomes a plus b cubed, and the second bracket, well, we can factorize out 4ab, and then we're left with, on the inside, a plus b. We can further factorize out a plus b from both our terms. We have a plus b squared plus 4ab to do a plus b. Let's evaluate the square brackets. We've got a plus b squared, which is a squared plus 4 plus 2ab plus b squared plus 4ab gives our middle term 4 more, so we get 6ab. And now I don't see us factorizing any further, so what we can do is simply substitute x cubed and y cubed instead of a and b. So we have x cubed plus y cubed, and a squared becomes x to the 6 plus 6x cubed y cubed plus y to the 6. And that's as simple as we can get, alright? So that is the first question factorized. Question number 2. If x squared plus 2x plus 5 is a factor of x to the 4 plus ax squared plus b, find the value of a plus b. So we know x squared plus 2x plus 5 multiplied by some term gives us x to the 4 plus ax plus b. And we know that this term that multiplies x squared plus 2x plus 5 must also be a quadratic. Why? Because if we multiply two quadratics, we're left with a quartic, as on the right hand side. So let's call this x squared plus ax plus b. Now notice how our quartic doesn't have any x cubed. It doesn't have an x cubed, nor does it have an x term. Now how does this come about? Well, an x cubed comes about when you times into quadratics, is when you times the x squared term by the x here. So x squared times ax, and it also comes about when you times the 2x by the x squared. 2x by x squared. Now we know that these two terms, this term here and this term here, sum to give us 0x cubed. So if we just quickly evaluate our terms, let's drag this a bit over. X squared times ax equals ax cubed, and then this becomes 2x cubed. Since we're adding these, 2 plus ax cubed, what value of a gives us a coefficient of 0? Well, that's a equals minus 2. So we can swap this a for minus 2. And we can apply a similar logic when we're dealing with the x term. So we find the x term by two ways. We times 2x by the constant, so 2x multiplied by b, or the 5, the constant in the first bracket, multiplied by the x term in the second, so 5 times minus 2x. So let's have a look. This becomes 2xb, or it's better write as 2bx. This becomes minus 10x, and these sum to give us 2b minus 10x. So 2b minus 10 equals 0, 2b equals 10, b equals 5. So now we can say b equals 5. Cool. So we now know that x to the 4 plus ax squared plus b equals x squared plus 2x plus 5 multiplied by x squared minus 2x plus 5. From here we can notice that this is just difference of two squares. If you like write as such, x squared plus 5 plus 2x. Let's call this a, let's call this b, x squared plus 5 minus 2x. Let's call this a, and let's call this b. So a squared minus b squared, so we've got x squared plus 5 squared minus b squared, 2x squared. X squared plus 5 just becomes x to the 4 plus 10x squared plus 25 minus 4x squared equals x to the 4 plus 6x squared plus 25. And this is our a term from the question. This is our b, and the question is asking us to find a plus b. A is 6, b is 25. So a plus b equals 6 plus 25, which equals 31. Finito. Okay, that was not too bad. On to the next. Factor ab plus cd, a squared minus b squared plus c squared minus d squared plus ac plus bd, a squared plus b squared minus c squared minus d squared. Now there's a bit of symmetry going on here. Like we've got the same terms in the bracket, in these brackets, just the signs before them are different. AB plus CD is fairly similar to AC plus BD. Right, so let's have a look. what can we factorize out? So both of the bigger brackets have an a squared minus d squared. So if I factorize that out, a squared minus d squared. So if I take that out of the first bracket, if it ab plus cd, let's put that in brackets there, and factorize a squared minus d squared from the second bracket, left with ac plus bd. But by doing this, all I've taken out are these terms, d squared, these terms and d terms. So we're left with minus b squared plus c squared minus c squared plus b squared here. Notice that the difference between these two is just that one is times by -1 of the other. So we can continue to factorize here by saying plus c squared minus b squared. Then factorize the rest out. So the first one, well, we have a c squared minus b squared here. So we can just simply factorize out ab plus cd. And then here, we've got b squared minus c squared, which is times -1 of that. So we take the negative of ac plus bd. Right. I think we can simply factorize these two terms because it's just difference of two squares. Now we just need to find a way if we can simplify what's in the square brackets. So let's look at AB plus CD plus AC plus BD. Well, we can take out A from two terms and we can take out D from these two terms. So we've got D plus BC. We've got common factor of B plus C in both of these terms. So we can factorize that out. So we've got BC plus A plus D. Now if we go over here, we've got two terms involving A, two terms involving B, two with C, two with D. So let's apply similar logic here. Let's factorize out A. So we've got A, B plus C, sorry, minus C that is. And then we factorize out D. So plus D, C minus B. And then, well, B minus C and C minus B, again, are just times -1 of each other. So if we take out B minus C, we've got B minus C. And we've, if you factorize B minus C from the first term, we have A. Second term, we have minus D. So if I rewrite our expression now, A squared minus D squared becomes A plus D, A minus D, and then B plus C, and then A plus D minus C squared minus B squared. So plus C plus B, C minus B, C minus B, and then B minus C, A minus D. Can we factorize anything from both these terms? So we can get A minus D can come out. We can also have, oh, there's B plus C here. And is there any way we can get B plus C here? Yes, we can. So we can have a plus d, a minus d, and then b plus c. The way we can do this is put a negative here, and that should become b plus c. And then first term is a plus d squared plus, taking out b plus c, so that's minus b wait a minute, there was no need for this step here because we already had the b plus c here, so we can say plus c minus b, b minus c. Okay, now can we simplify this any further? I believe we can. C minus b and b minus c, well, that's just the same as saying minus b plus c, sorry, no, minus b minus c, b minus c, which just becomes minus b minus c squared. Then you fry out the rest. A minus d, b plus c, a plus d squared minus b minus c squared. Alright. Anything else we can do? Well, now we can just simply expand these here and hope to see something nice. So a minus d, b plus c, and then we have a squared plus 2ad plus d squared minus b squared minus b squared minus 2bc becomes plus 2bc plus minus c squared. Right, so we've got 4 terms, and we have 4 terms which are quadratics, and 2 terms with coefficient 2. So we can start grouping these together somehow, or we can sort of factorize this by a method of guessing. So the a squared implies that there's an a in both brackets. So does the d squared, sorry, b squared, so does the c squared, so does the d squared. And then same for the other bracket, a, b, c, and d. Now we just have to make sense of the signs. So a, well, if I look at all the a terms, they're all positive, a squared and 2ad, so that's fine. B, well, we've got a minus b squared and a 2bc and a minus c squared, so I'd like to say that this would have a minus, this would have a plus, and since we've got 2bc, that comes from multiplying 2 negatives, so there'd probably be a minus c there and a plus c there. What else? D squared, 2ad, positive. Well, that's it. I don't think we can get any more simpler than that. And clean result. Okay, now we're factorizing ay plus bx cubed plus ax plus by cubed minus a cubed plus b cubed x cubed plus y cubed. Again, there's a lot of symmetry here, but I don't see us factorizing this as our first step. So let's just expand these cubics. So ay plus bx cubed. Using the identity we used earlier, we know that this equals a cubed y cubed plus 3 a squared bxy squared plus 3a b squared x squared y. Our last term b cubed x cubed ax plus by cubed. So we can use the same identity, a cubed x cubed plus 3a squared bx y squared. Is that right? Yeah. Sorry, x squared y plus 3ab squared x y squared. Good. And then the last term plus b cubed y cubed. Right, and we're told that we need to add these two brackets, so let's put an add sign here. What looks most similar? Well, you know that these terms are very similar, so we can sort of group them, and these terms here, the first, the last, here and here, they also look quite similar. So let's start by grouping these two here and these two here. So a cubed y cubed, a cubed x cubed, b cubed x cubed, b cubed y cubed. So you've got, what is that? We've got 4 terms, no signs of quadratics. So I believe we can, so let's just evaluate this down on the side. A cubed y cubed plus a cubed x cubed plus b cubed x cubed plus b cubed y cubed. So let's factorize out a cubed. A cubed. So we have a cubed plus y cubed. Factorize b cubed, we have x cubed plus y cubed. Notice the brackets, so you can say a cubed plus b cubed x cubed plus y cubed. Yep, that makes sense. So let's shrink all this and bring this up here. Alright, let's draw a line through the terms we have factorized. Now this looks quite menacing, but I think it's one of those ones when you factorize you get a pretty nice result. So you've got 3a squared b xy squared. Just quickly write these out again like we did with the first few terms. So a3a squared b xy squared plus 3ab squared x squared y, and then 3a squared b x squared y plus 3ab squared xy squared. Right, so let's take out 3a squared b from this term here and this term here. 3a squared b xy squared plus x squared y, then plus 3ab squared from these two terms. So we're left with x squared xy squared plus x squared y. What we can do now is group these two terms by factorising the bracket from both of them. Xy squared plus x squared y, 3a squared b from the first time, and 3ab squared from the second. Oof, that's looking a lot nicer now. So let's move this up here. And remove all this. So if we go back to our expression, we've essentially evaluated the first two terms. Now we just need to minus a cubed plus b cubed, x cubed plus y cubed. Well, this happens to be quite nice. We can simply just cancel this term here, and we're left with xy squared plus x squared y plus 3a squared b plus 3ab squared. Well, I believe we can factorize this further, so let's take out from this bracket 3ab, and from the first bracket xy. So the first bracket becomes x plus y, and this becomes a plus b. Let's write this in order. X plus y, and voila, we've got a pretty neat factorization that looks much simpler than what it was before. So good job to me, I guess. Yeah, and those were just some 4 interesting Olympiad style factorization questions that I hope you enjoyed. I hope to be doing a lot more of these Olympiad problems soon and keep them posted on the YouTube channel. So thank you for listening and watching. Hope you learned something. Goodbye.